All right, hope you can hear me. Hello, everybody. My name is Jakub. I work as a DevOps engineer at diva-e, and today I'd like to take you on a journey. On a journey that we've been on for approximately 2 years. And during that time, we made quite a few mistakes. And those mistakes resulted in a bunch of failures. So I hope that you're going to learn from our mistakes and would avoid that in your projects. So first, let's set the scene. In this case, that was an e-commerce project. A project like this, which is a fairly large one, contains a lot of moving parts, and AEM was one of them. That was a headless JSON API, which was meant to return just JSON in like 99.9% of cases. There is one exception. We're going to get to that in a second. It was based on Sling model exporter, so a fairly standard approach. The whole API was designed to be hyperlinked. So everything, all you need essentially is an entry point to that API. So you enter the first URL, and then you can discover pretty much all those nooks and crannies of your API. And last but not least, there was a custom SPA editor, mainly to provide that what you see is what you get capability, mainly because if AEM returns just JSON, it's kind of hard to visualize what you're going to see eventually without publishing the content. All right, so let's look how it was made and put things into perspective. So first of all, we have a Vue.js application. So you type in the URL, that's the main site. And that request goes to Nuxt. Nuxt is our server-side rendering component. It also runs that Vue.js code base. And in order to render anything, it has to fetch some data. And in this case, of course, it has to fetch the content first. And that's where AEM comes into play. So we fetch some JSON, actually a bunch of JSON objects from AEM. And aside from that, since that's an e-commerce project, we need to fetch some extra data, and Nuxt essentially stitches all of that together and produces an HTML. And just because this is a single-page application and that hydration client-side rendering kicks in the browser will also communicate with all those APIs, including AEM. All right, so let's look at the structure of the JSON itself. So here's the entry point. It is fairly straightforward. You have a self-reference at the top, and the languages array at the bottom, which points you to index.json. The index.json contains a bunch of references, and if that looks familiar to what you've seen in Stefan's talk, that's a good idea, just because that was like a predecessor of that site API, in WCMIO site API. So in the index.json, you can see there's a bunch of references, and let's say that we'd like to render the homepage. So we're going to fetch the content. And here's how the content looks like. There's a bunch of fields here, but there are two crucial parts. The first one is that we have two containers, breadcrumb and content. And there's a very specific order in which they should be rendered. So breadcrumb goes first, content goes second. Within that content container, we have two components, rich text and title. And in a similar way, there is an items order element which defines how to render that. So a fairly standard thing. And now the fun begins. We need to go back to June 2021. That was the very first time we faced a misrendered JSON situation. I wasn't even working on this project at that time, but a colleague of mine posted a comment in Jira, which is mainly like this. So he was really precise in his statement that approximately 29% of AEM requests ended with a misrendered JSON. And that JSON returned a 200 response, so at least in theory, that should be all good. But what does that mean that the JSON was misrendered? That means this. As you can see, there's no content at all. The content literally vanished. There's no components, no containers, literally nothing. Essentially an empty structure. And when anything like this happens, there's a number of reasonable explanations, like what could possibly go wrong. So first of all, maybe someone just deleted that content accidentally or unpublished the page. That happens, right? Maybe there was a deployment problem and we installed things in the wrong order, or maybe something got cached. We had a really bad luck. There was some sort of a race condition, and all of a sudden we ended up with a misrendered JSON. Or maybe there was a maintenance going on or some sort of a downtime, and all of a sudden it resulted in such a JSON. So we started looking into that. What is the actual reason behind that? What is going on behind the scenes? And first of all, that's the beautiful situation that everybody loves, that you can't reproduce that on your local. No matter what you do, you just can't. It happens only in the cloud. That was the AEM as a cloud environment. So we started to adding some extra debug statements to our code, introducing extra debug headers just to understand the whole situation a little bit better. We also noticed that whenever you reactivate the page, the problem just goes away. That's all you need to do to fix the problem, which was a pretty strong indicator that something got incorrectly rendered by AEM publish, and it got cached, and then it simply propagated to all the layers and effectively to end user application. So in order to see what's going on and what gets cached where, we introduced some cache bypassing tricks just to compare what's in the CDN, what's in dispatcher, and what is being rendered by AEM publish itself. And of course, just to make sure that we identified the time frame during which it happened, so we can correlate that with, I don't know, like a deployment or content ingestion or anything like that, we set up some monitoring to effectively every couple of seconds request that misbehaving endpoint from different locations. And at that time, we didn't really know what we were doing, but that sentence summarizes it perfectly. That guy was a British economist, so we decided to collect a bunch of data, and we decided to torture that to get some results out of that. So what was the result of our analysis? First of all, around that time, there was a really nasty issue in AEM as a cloud. That was related to Loki, which is like a log aggregation platform that Adobe uses behind the scenes. That was in Loki 2.3, and that was all about out-of-order events. So if you happen to have a log entry that came in out of order, all such events got dropped. So imagine that you send like 100 requests to your AEM, and if you assume that all the caching layers will be bypassed, you would expect to see 100 log entries in your log file. But that would vary by your luck, I would say. So you would usually get like 30 to 60-ish at best, which of course didn't help when we were investigating the problem. Thankfully, it got fixed a couple months later. All those debug statements that we added to the code, they didn't produce expected results. So when the correct JSON was rendered, everything got printed as we instructed the code to do, but when we were facing the invalid JSON situation, there was no log entries whatsoever, so literally nothing. We also noticed that it is no longer just a single endpoint, but a bunch of them that return invalid data. Another interesting observation here was that when you bypass the cache, it is literally impossible or practically impossible to observe the problem. So the issue is very short-lived in nature. So it is like broken for a couple of seconds, then it gets cached, and that's how it propagates to all the layers. And another observation here, which is super important for the rest of the talk, was that it usually, in like 90% of cases, that starts with a warm-up request. And a warm-up is a special service that runs in the cloud, but we're going to talk about that in a second. So the warm-up is like a built-in feature in the cloud infrastructure. And it works in a way that, first of all, it waits for AEM to become available or fully initialized. So if you're familiar with Kubernetes, there's a bunch of like probes, like liveness probes, readiness probes, startup probes, and that system-ready endpoint is actually used by the underlying Kubernetes infrastructure that powers the cloud to wait for AEM to be fully initialized. So as soon as system-ready returns to 100, your AEM is fully up and running. And then warm-up service kicks in, but that's still before that instance is plugged back into load balancer in front of it, or Kubernetes services, if we'd like to be precise. So the warm-up service, the reason it exists is performance. So you'd like to pre-populate your dispatcher cache with some data, simply because to avoid overloading AEM publish when you receive some traffic and when you plug that instance back to load balancer. It requests all the most popular URLs from the last 24 hours, and it takes host header into account to essentially address multi-domain setup. All right, so that's enough about system ready and warm up. We're gonna discuss it later. But when that was happening, of course, it is pretty annoying when you work with any application that is meant to consume AEM data or that JSON data. It's like, let's say that you'd like to implement some component, and that component disappears in every third attempt that you send a request to AEM. So that's pretty annoying. And people were complaining a lot, and I don't want to blame them. That was a pretty unreliable solution at that time. So just because it was super hard to notice the problem with caching enabled, it's been decided to just disable caching completely. We were still at the very early stage of development, so that was fairly okay to just disable and just let people work and avoid all those nasty issues. In parallel to that, we were talking to Adobe regarding the whole system-ready warm-up service situation, as we wanted to understand what actually is happening on the infrastructure side or Kubernetes side. And out of those discussions, we ended up with 2 tickets. That was the first one, which turned out to be a dead end, unfortunately, as that was like a classic chicken and egg problem. And another one, which was a slightly different approach to the same thing, got delivered by Adobe by early September 2021, so over 2 years ago. All right, so the fix got delivered, it got released. I would say that was a pretty snappy implementation. It got released in this particular version. We upgraded, we decided to re-enable caching, and we gave it some time to actually make sure that that fix from Adobe fixed the whole thing we were facing. So that was exactly September 14th. I remember a comment from a colleague of mine. He posted a hooray comment in Jira that, hey, we finally made it. But we didn't have to wait long. 6 days later, it started to happen again. And at that time, we didn't really know that we're at the very beginning of that, and we're gonna start playing a whack-a-mole game for the next couple of months, or actually years. So what happened this time? That's a config.json. It doesn't really matter what kind of properties you can see here, but what is the most important part here is that there's a bunch of asset data here. So you have some width, heights, some links, and whatnot. And that's how the JSON is supposed to look like. But that's what we observed instead. Like literally all asset data vanished. That was gone, truly gone. So what happened? So first of all, investigation kicked in again. And we also discovered that, hey, that's a warm-up service again, so maybe the fix just didn't work. Another observation was that only 1 out of 2 published instances got affected. So if you're requesting the same thing, it was like 50% success, which was super annoying. It lasted for around 6 hours, and as usual, reactivation fixed everything. So with that knowledge, we started considering like an alternative approach or an alternative way to troubleshoot all of that. So first of all, there's clearly something going on with that system-ready endpoint, that it doesn't wait long enough for the application to be fully initialized. And because in this case, we were facing some missing data related to assets, our first thought was, hey, that's related to dynamic media, because we were using dynamic media here, and we had a bunch of issues regarding the whole dynamic media integration. So that was also a possibility that maybe this is not system-ready thing, but maybe something related to dynamic media itself and its integration with AEM. Another thing that got noticed here is that when you do not use any compression, when there's missing accept encoding header in your request, it just works, which was yet another strange behavior throughout this journey. Of course, it didn't make things easier. And we really started to looking into the system ready itself as like, what it actually takes into consideration to determine whether a given instance is fully up and running or not. But aside from all of that, we were really struggling to understand what's going on, as our code wasn't designed in a way to break like this. So there was no logic that would indicate that, hey, when something is wrong, just do not render a certain section in the JSON object. But anyway, we decided to deep dive into the system-ready part of things. So here's how it looks like. You can request it in your local instance, and you're going to get a JSON which says, hey, or your bundles are up, or your components are up. So that's how it works. And I was really desperate and determined to reproduce the problem on the local AEM environment. It's like debugging things in the cloud is always challenging. So there must be a way, if that happens, there must be a way to reproduce that on the local system, as otherwise we're never going to get to the bottom of it. So I started a pretty naive approach. So I restarted my EM, and I started taking snapshots of different endpoints. And by endpoints, I mean the system ready itself, all OSGI endpoints related to bundles, components, and services, and that misbehaving JSON. So like the instance was starting, and at the same time, I was like snapshotting all those endpoints just to maybe hit a situation in which that wrongly rendered JSON shows up. And as a part of that activity, it took me quite a few attempts. That was quite a, I would say, time-consuming activity to discover all of that. As you can imagine, if you snapshot that amount of data, you're going to end up with thousands of files to analyze, which is quite annoying to do, especially if like they have different formats, and sometimes there's no JSON, and like there's like a generic error message like 503 from AEM. But anyway, I identified like 3 unique, distinct stages that take place during that startup process. So first stage is that when AEM, the system ready from AEM returns 503, and the JSON returns 404, so that's the very beginning of the startup process. The second stage is when system ready still returns 503, but there's a good thing that finally happened. We finally managed to observe the broken JSON on our local environment. The third stage was like this. So the JSON started to return correct data, but system ready was still returning 503. And finally, everything was green, so everything was working as expected. And when you look at those unique stages, none of them is actually the thing that we were looking for, as I would expect to see system ready 200 and an invalid JSON 200 plus some data. That's what I would expect to see. But that didn't happen. Still, that was a really positive situation and some sort of a breakthrough here, that it finally happened on a local system. So at least there's something tangible that we can work with. So I decided to continue with my experiments, and they can be summarized to a simple loop. So according to what I got in those state snapshots, it was most likely a fault of one of our components, OSGI components, that results in that misrendered broken JSON. So I decided to start a loop like this, super naive, which is like, give me all the components, and for every single one of them, stop it, request the JSON, see what it returns. If that's invalid JSON, just save it, start the component, and repeat the process for the next one. And there's like a 2,000, 3,000 components on an instance, so that, as you can see, that may take a while to analyze. But I found a few. I found a few that actually produce that wrong JSON, which was super, I mean, like an extra news here that like, hey, we finally have something that makes sense that we can work with. And our first idea was to create a custom health check. A custom health check was like, okay, we can just collect a bunch of state information from all those components and essentially turn 200 or 503 and somehow plug that into system ready. But it turned out there's a better way. You don't really need to write a custom health check. You can extend the built-in system ready endpoint with a set of custom components. So that's what we did. That's the config, OSJ config for DS component check thing that allows you to extend the default list of OSGI components, bundles, and whatnot to essentially be included or be respected by that's built-in system ready. So that's what we did. And as a part of that exercise, we discovered that you should really pay attention what you put on that list. As like, if you put a non-existing component here, you're gonna waste an hour and a half for your cloud deployment to finish, and at the end you're gonna get a message which is kind of vague or super unclear that something is broken but you don't really know why. And the same applies to component renaming or refactoring. If you ever change the name, just make sure it is reflected on the list, as otherwise you're gonna waste even more time. So that was around December, end of the year. So we're talking about 6 months time frame right now. We finally managed to fix the problem. So we fine-tuned the list as like there was a few dependencies between those components, so we could shorten it a bit. And we finally announced the success, which was kind of nice, as that was the end of the year. So an achievement like this was definitely desired. But we didn't have to wait long. 5 to 6 months later, that was the end of May, beginning of June, our favorite broken JSON returned. And this time, it was like this. I'm not going to go into details, but as you can clearly see, there's missing data here. And this time, it turned out to be related to the development gap. So over those 5 to 6 months, we added a bunch of new code, and we didn't bother about updating the config. So we ended up with broken JSON again. So this time, it was super simple. But let's move on a few months to September 2022, so a year ago from now. And another flavor or another variation of the problem showed up, which is described by this sentence, like unexpected JSON cutoff. And what does that mean in practice? It means this. So as you can see, the JSON ends with an opening square bracket. That's not even a valid JSON syntactically, like that's just the beginning of the JSON. That was the end of the HTTP response body. Like there was nothing else here. That was the thing. And like when that happened, my first thought was like, that is broken beyond repair. You just can't fix it. I mean, like something is so wrong with the whole thing that you just can't fix it. But there must be a reasonable explanation. I mean, like someone either programmed that in a way to break this way, or maybe we just have some sort of a regression or a bug that got accidentally introduced into the code base. And I'm not going to pretend that I know what actually got fixed here, but Stefan created a ticket, a Sling ticket, this one. And when you look at the pull request, only 2 lines of code get deleted. That's totally beyond my area of expertise, so I'm not going to pretend that I know why removal of 2 lines of code fixed the problem. But we have a number of Sling experts here, so if you're interested, you can feel free to reach out to them. So that got released in Sling 2.11, and we, of course, had to wait for a corresponding AEM release to incorporate that into our application. And that happened, so we upgraded, and the issue was gone. At least that's what we hoped for. But the story doesn't end here. If you remember those assets issues that we had with missing, like totally missing dynamic media and like asset data in general, we experienced something similar a few months later. But it broke in a way that we never intended or never programmed to break. So this time, instead of missing data, we got invalid data, as like our application was designed to render dynamic media links. And AEM is supposed to render just JSON. All those assets should be delivered by dynamic media itself. But we ended up with some DEM links. So that's the expected correct JSON. You can see that we have that assets example.com, blah, 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 and so and the path to logo. But we got this instead. So this is like a direct DAM link to a rendition. And of course, that is not desired behavior simply because all those dynamic media features are not available. I mean, like smart cropping and all those fancy other image processing features. But that doesn't really matter, as we intentionally blocked access to DAM, as like you should never request DAM directly. So those links were not even working, and they were returning 404. So all the images, they disappeared from the site. So what actually happened here? So first of all, we didn't configure dynamic media everywhere. There were environments without dynamic media, and it all boils down to licensing. I mean, like even on your local, you typically do not configure dynamic media. So there are differences or discrepancies between your local or some sandbox environments and real environments. As I said, we explicitly blocked access to DAM. So all those links that got rendered instead of dynamic media, they started to return 404. And that was because our logic, or the logic in our code that's supposed to detect whether we have dynamic media enabled or not, was relying on this particular node. This is a JCR path, so that conf global settings DM S7 enabled. That was a path in your repository. And when it exists, it is a suggestion that, hey, your dynamic media is enabled on your instance. But it turned out that that was working quite okay for, I would say, year and a half. And then that node disappeared from published instances. And that was deliberately removed by Adobe simply because it doesn't have to be there. There was a bug. I do not have a ticket number in mind, but that got removed on purpose. So all our logic that's supposed to detect whether dynamic media is or isn't enabled, it started to fail. And that was also combined with availability of preview published instances. So they got added later on, and they got created without that node existing. So like if you had an old environment that got provisioned like, I don't know, a year ago, that node was there. But for any new environment that got created later, that node was simply missing. So we had to reevaluate the way we detect whether dynamic media is enabled or not. And this time, we decided to do it on a per asset basis. So if you have an asset referenced in a component, you need to check whether a given asset has all those dynamic media properties enabled or not. And that is a much better way, or much more reliable way. Although I do have one concern regarding that, but maybe we can catch up and discuss that when my talk is done. And finally, we also introduced a flag that controls that fallback logic. So we can control whether we even want to introduce that DAM fallback or not. So maybe when dynamic media is not enabled, we simply should skip the component entirely if there is no proper dynamic media property in place. And that feels like that's the end. And I really thought that that's going to be an end. As like that was a quite unfortunate situation. As like when I submitted this talk, I thought that we kind of resolved all those different flavors of this particular bug. But I was kind of wrong, as in June 2023, so 3 months ago, we observed yet another variation of the problem. That was our favorite JSON cutoff situation. So like the opening square bracket as the last character of the JSON body. And this time, it wasn't that bad, thankfully. That happened for our custom SPA editor, so the thing that I mentioned at the beginning, that we do have it. And that custom SPA editor also fetches data from that content API, that JSON API. And that happened on one particular environment for only specific group of people, which was most likely related to some antivirus or proxy stuff. It's hard to say, to be honest, what was the actual reason. But the actual problem was related to the fact that we didn't upgrade that particular instance to the version which contained that Slink version. So like we were essentially running the old code there. And we did that because we had a lot of issues with auto upgrades of AEM. But that is probably something we can discuss next time, as that's all I had.
Thank you, Jakub. Your presentation must be excellent. Now the questions came. I just wanted to say it's all clear, no question, not right. Quite right from yeah. All right. What would you recommend? What would you recommend to others to mitigate those issues? Are you, e.g., extending the health check for all future projects?
I would say so. Actually, there's I'm not sure if I can share that, but I'm going to say it anyway. We heard from Adobe that at some point, information regarding that system ready and how to extend that was part of official documentation. But at some point, it got removed as apparently someone considered that not necessary, that you shouldn't really mess up with that. So it got removed. But I would say that this is a must-have. And like, even if you're not observing something similar in your application, that doesn't mean it doesn't happen. It may happen, but you're just not detecting it. So I would strongly suggest to reevaluate that and make sure that you do not have something similar in your app.
Konrad would like to know, have you raised an issue with Sling models exported to no longer return a 200 when exceptions are happening in some of the models, or they cannot be initialized at all?
Yeah, so there was a follow-up to that. I think that Stefan did a great job when it comes to this. So that's one of the Sling tickets that I mentioned here was just the beginning. There were some further updates to the whole thing. I think that one of those WCMIO libraries received some extra fixes, essentially to incorporate that fix that Stefan did and stop rendering 200 if there is a problem with one of those elements that you try to fetch. So that is no longer happening for us. But if you're looking for details, then probably Stefan is the guy to go to.
Excellent. Henry would like to understand, if he understood it correctly, your Sling model exporter. Sling model didn't require the appropriate adapter definition to be there. You had to delay making them work to have the resource to asset adapter to be there, for example.
Yeah, so I believe this is closely related to that Sling ticket. So there was some sort of, and I'm going to explain it at a very high level, as like that's not my area of expertise, as I said. But there was an intentional fix to return 503 whenever we can't fetch all the data within given time frame. So like, I don't know, like if our timeout is like, I don't know, 5 seconds, and if we can't render it, we should never render something like this, something like that broken cutoff JSON. But again, that's beyond my area of expertise, so please approach our Sling experts here for more details.
Thank you, Jakub.
All right, thank you so much.